Hello again. Welcome to another episode of Getting to Know the Renaissance PTX NFC Solutions. In this video, we are going to take a look at the software development kits that come with the PTX modules. The SDK contains the code libraries, APIs, documentation and integration notes, and an example implementation of NFC reader application. The PTX NFC modules are supported by two SDKs, an OS version and another non-OS version. The non-OS version can be used with devices without any OS at all, or it can be used with RTOS systems. The OS version contains the stacks for integrating NFC with operating systems such as the Linux OS. Both the SDKs come with standard documentation outlining the use of the APIs and integration and portability notes. We can see from the list the APIs available with the stack such as initialization, card activation, discovery, data exchange, and so on. For the non-OS version, there are currently 23 APIs, and for the OS version, there are 25 APIs. There are also 4 APIs in each stack for host card emulation. So, the SDK provides full support to developing a PTX application as card reader or host card. In the next segments, we are going to look at the contents of the SDK. First, we are going to look at the contents of the OS SDK. The stack can be divided into 3 layers: the application layer, the platform independent layer, and the platform dependent layer. The platform independent layer comprises the NFC soft controller stack, or NSC in short. The platform dependent layer comprises the implementation of the different communication and GPIO protocols. The SDK folder contains the subfolders build, docs, file system, and source. The build folder contains a shell script for a pre-built Linux-based application for the Raspberry Pi. The docs folder contains the documentation for API and integration notes. The file system contains the RF configuration files. And finally, the source contains the API components and the example application. Navigating further into the API folder, we can see the GPIO configuration source file. The example folder contains the project file for the sample application. Now, navigating to the components folder, we can find the platform dependent files. For example, in the PTX platform file, we can see the various platforms that can be enabled for this module. For each module, the relevant macros are already defined and get enabled when a particular platform is chosen. Going back to the example application, we can check the various implementations of the APIs related to the NFC reader application. There are several configurations made for the appropriate OS to be used. And then the API calls become independent of the platform. Let's navigate the file a little more. Next, as we look in the architecture of the non-OS stack, we can see the 3 layers: the application layer, the hardware independent layer, and the hardware dependent layer. The hardware or platform dependent layer is the one where we define the pin configuration, setting for communication protocol, and settings for timers and interrupts. Once these have been set, we can work with the components in the application layer, which is primarily defined in the IoT reader file. This file consists of the API definition and interfaces for the different NFC protocol implementation that comes built in with the SDK. In the non-OS stack, the SDK folder contains 3 subfolders: docs, source, and tools. Docs folder contains the documentation files and source folder contains the component files, and the example application. The example application file is located in the IoT app folder. Now, we will have a short tour of the example project that is bundled with the SDK. We need to access it via the eSquareStudio environment. First, we open the eSquareStudio and import the entire SDK zip folder. This will load the project and configuration files. We can see that the example project has been implemented in the RF4M2 platform. Navigating to the Stacks tab, we can observe the stacks that have been used to build the example application. The stacks responsible for the NFC communications are the interrupt stack, the timer stack, and the SPI stack, which is configured with the PMOD2 port. It is important to use the right PMOD port that is connected to MCU pins which support SPI communication, since modules like the PTX-105R only support SPI. In general, the PTX platform supports I2C, UART, and SPI for NFC communications, hence they are pre-configured in the default stack. As for the program, we can see that the hullentry.c file only executes the PTX app entry function, which is an external function defined in the application source file PTX IoT main.c. This function then executes the reader app function, which comprises the implementation of the reader functionality. Now, navigating to the components, we can see several folders which are the platform independent implementation for each functionality and configuration. For example, the PTX GPIO file contains the macro definitions required by the generic GPIO configuration. Among these folders, we have one folder which are of interest to us, that is, the platform dependent configuration files. We can find them within the plat folder as we navigate to Renaissance and then to RA4M2. As we will notice here, there are several files with the prefix PTX plat. This refers to the platform specific source files which need to be modified for different platforms. Looking at the platform GPIO file, we can see that the IRQ pin to be used has been defined here. The rest of the program will refer to this function, so it is important to make sure the right interrupt pin has been defined here. Then, for the SPI file, the SPI channel has been defined here. So, depending on the stack settings, we need to define the correct channel here, since that is the link between our configuration in eSquareStudio and the source library. Moving on to the IoT Reader folder next, we can see the definitions for the various APIs for this module, that is, the API for initialization, card activation, data exchange, protocol selection, etc. Note that this file must not be altered as this serves as the source for all the API implementation. So, with that, we come to the end of our small presentation today. We have gone through the contents of the SDK that is provided with the PTX modules and also seen one of the SDK versions imported into eSquareStudio, which is the native development environment for most Renaissance boards. In the next videos, we shall see how we can build application using this SDK. Until then, bye bye.